Everyone, today we are going to study friction. It's lesson 5.2. In this lesson, we are going to define friction, differentiate between the two types of friction, and use the coefficient of friction to calculate frictional forces. Uh, so to start with, friction actually is a very common term or force. We experience it in most of our daily activities. Um Actually, friction is the reason we can walk, we can run, we can stop, we can jump. And so friction is actually kind of a force that we need to perform our activities. Like imagine trying to play basketball while wearing socks instead of shoes, athletic shoes. How would it be like? Of course, you would slip, you would slide all over the court. But with the shoes, you feel it's more comfortable to run, to jump, to turn, to whatever. And this is because the shoes creates or create more force of friction than the socks. The socks and the floor has less friction than the shoes and the floor. And in such cases, we need a greater force of friction to stay like kind of tight to the ground, to the floor, not to slip and slide. Okay, so the shoes here help provide the forces for the player necessary to quickly change direction while running up and down the court. So, as I said, that friction requires rubbing between two surfaces. When two surfaces are rubbing against each other, then we say that there is friction. So friction force exists when two surfaces rub off against each other. And always force of friction acts in a direction opposite to that of the motion of an object. If an object is moving in one direction, let's say here to the right, because of this applied force, due to the rubbing between the object and the surface, there will be a force of friction acting in the opposite direction. And if an object is given a push, let's say a book, you slide or you give a push for a book on a table, the book will slide on a table, then eventually it will stop. So it stops because the force of friction between the book and the table. So as an object slides on a surface, the force of friction will slow the book down and eventually will cause it to stop moving. As we are going to see in this video here, this lady is throwing this book on the floor. We will see it will slide in this direction. This direction of motion, friction is always opposite. It will slide until it comes to a stop. Okay, so always force of friction opposes motion and tries to stop the motion, to seize the motion. Okay, actually there are two types of friction. One is called static friction and the other is called kinetic friction. Static friction is represented by Fs. Kinetic friction is represented by Fk. Uh, Kinetic friction is motion. Kinetic means motion. It's obvious that an object, a moving object, like experiences force of friction due to the rubbing between the two surfaces. So kinetic friction is the force exerted on one surface by another when the two surfaces rub against each other, either because both are moving or because only one of them is moving. So we are like, it's more obvious that moving objects experience friction. But how come objects that are not moving experience friction? From the term here, static friction, static means no motion. How can an object that is not moving experiences static friction? First, let's read the definition here. It's the force exerted on one surface by another when there is no motion between the two surfaces. هلا, example on static friction. If you are trying to push something heavy, like a fridge, first you push it with a small force. You feel that the fridge is not moving. Although you are pushing with a force, the fridge is still at rest. This means that, of course, there should be a force opposing the force. This force is friction. Because the fridge is not moving, then this force is called static friction. This is where static friction exists. And to learn more about the two kinds of friction, I will show you here a demonstration where I have a guy or a robot or whatever and a wooden box on a surface. Okay, here applied force. I will apply a force. Apply a force, and this person will apply a force. Okay, now if I apply a force of 50 Newton, you will see that the box does not move. It does not move because of the friction force. This friction force is called static friction, force of static friction. If I increase it, I make it 60, you will observe that the force of friction also goes up to 60. If I make it 20, it drops down to 20. So what do we notice here? We notice that the force of friction, the force of static friction, actually works in response to the applied force. If the applied force increases, static friction increases. If the applied force decreases, the force of static friction also decreases. Let's take the case where I am increasing the force, the applied force, like 100. So, do you think if I keep on increasing applied force, the friction force will keep on increasing? Yeah, of course not. If I make this 110, yes, it's still not moving. If I make it 120, still not moving. But if I make it 130, still not moving. 150, 180, because the surface is very rough actually. 225, here it moves. The maximum friction it can reach to is 201. 225 exceeds 201, the object starts moving. Once it starts moving, then this force is no longer static friction, it's called kinetic friction. Okay? So this is what we meant by static friction. So remember, always static friction works in response to the applied force. So when you push the box with a small force, small horizontal force of applied, the table exerts an equal force in the opposite direction. We are assuming here this is a box on the table. As long as the box doesn't move, Fs is equal to F applied, and Fs is opposite to F applied. As F applied increases, Fs increases, and as F applied decreases, Fs also decreases. If you push harder and harder, Fs, which is growing all the time, reaches a maximum value which it cannot exceed. This maximum value is called Fs max. So here you see here F applied is increasing, Fs is responding to this increase, also increasing. F applied here is equal to maximum static friction. Increasing the applied F applied more, so we are exceeding Fs max, the object starts moving, and Fs max now becomes Fk. F applied exceeds Fs max, so the object moves and the friction is kinetic. So here what we just said, if the applied force in the box exceeds Fs max, the box begins to move with certain acceleration. The frictional force is still acting in the box as the box moves. This force is the force of kinetic friction. And Fk is less than Fs max. I told you when you push the fridge, you feel it's hard to put it in motion rather than to keep it moving, okay? Because the static friction is more than the kinetic friction. Now, what are the factors that affect the force of friction? Number one, how hard the two surfaces are pressing together. How hard the surfaces are pressing together means it depends on how heavy the object is. Okay, because the more it is heavy, the more it exerts, the more it presses on the ground. And the more it's heavy, or the heavier the object is, the more normal force acting on the box from the floor. Okay, so more normal force, more friction force. The friction force is proportional to the magnitude of the normal force. Trying to push two boxes is harder than pushing one box, because two boxes experience more normal force or greater normal force than one box. So this is the first factor. First factor is the normal force. The force of friction depends on the normal force. Second, force of friction depends on the material that the surfaces are made of. It is easier to push the box on an icy surface than a concrete surface. Of course, the type of the surface affects friction. Smooth surfaces provide less friction than rough surfaces. Okay, again, to understand more, I'll give you an example here. Here also a friction. It determines the friction of the surface. Here I have low friction, here I have high friction. Let's consider the case of low friction. Taking the same box with a small force of 50 Newton, see the box will move. Okay? So 50 Newton with a smooth surface, able to move it, to set it in motion. Now, again the same box, but now a lot of friction. Let's see the 50 Newton. Is the 50 Newton able to put it in motion? Of course not. Not even 100. Okay, so the surface, the type of surface actually affects force of friction. Now, the surface, the quantity that expresses the dependence of the frictional force on particular surfaces is called coefficient of friction, and is represented by symbol mu, the lower case Greek letter mu. Okay, so coefficient of friction actually depends on the surface, whether it's smooth or rough. Okay, and it is the ratio of the force of friction to the normal force, F over F. Force of friction over normal force. Force of friction has a unit of newtons, normal force also Newton, so mu has no unit because Newton and Newton cancel out. Okay, so here it's not working. So this is N and this is N, so they simply cancel out, and mu is unitless or dimensionless, has no unit, and it's equal to Ff over Fn, force of friction over normal force. Now, if the force of friction is kinetic friction, the object is moving, then the coefficient of friction is called coefficient of kinetic friction, and it's equal to Fk over Fn. And in case of static friction, the object is not moving, but there is friction, the coefficient of friction is called coefficient of static friction, μs, and it's equal to Fs over Fn. And since Fk is always less than or equal to Fs max, then μk is always less than or equal to μs. That's all for this lesson. Actually, we still have a part about solving problems, how we can deal with problems. Two types of problems also: problems problems that involve static friction, and problems that involve kinetic friction. Thank you for watching. I hope you will enjoy, and I hope you will enjoy the video. and I hope that you will learn from this video. Thank you again, and until next videos, bye bye.